Let us understand few more terms in motion: uniform motion and non-uniform motion. Let's say an object is traveling, say 10 meters in first second, same distance 10 meters again in the second, again 10 more meters in the third second, again 10 more meters in the fourth second. So in each of this case, we see that the object is moving 10 meters every second, which means the object is covering equal distance of 10 meters in equal time interval. Every time the time interval was 1 second. Look at the picture. Can you see hands of the wall clock? Do you realize that the arms of the wall clock cover equal distance in equal time interval, and that is why we use wall clock, right? So every arm of that wall clock is going to cover equal distance in equal interval of time. This is called as uniform motion. The time interval, magnitude of the time interval does not matter. It could be milliseconds, second, hour, hours together, days, but it has to be equal for every section of that motion. Now let us see what happens when an object covers unequal distance in unequal intervals of time. Let us say you go for a jog. The other day you go for a jog, or your friend is walking on a track. Does your friend cover equal distance at every footstep? Do you jog equal distance in equal interval of time every day? You might say that every day I go for a walk for 1 hour, and exactly at the end of 1 hour I come back. But during that 1 hour, are you covering equal distance all the time? No. Look at the picture on the image. A person is trying to ride a bicycle up the hill. Okay? Do you think that the motion that the person is in is same all through his journey? Is it that he at every pedal he is covering exactly same distance? No, right? This type of motion is called as non-uniform motion. Let us study acceleration in this slide. We will be referring two cases. One, where object is in uniform motion, means object covers equal distance in equal time interval. And second, when object is in non-uniform motion, means object is covering unequal distance in equal interval of time. Case 1, where object is in uniform motion. Example, for a freely falling body along a straight line, the velocity is constant at any given time. The change in velocity is zero. Such we call this as there is no acceleration. Okay. However, when the object is moving in non-uniform motion, the velocity changes or varies with time. At different the velocity value will be different at different point. Let's take an example. Car moving along a straight road with varying speed. If we want to express the change of velocity, the rate at which the velocity changes, we need to know one more measuring quantity, and that one more physical measuring quantity is called as acceleration, and this type of motion is called as accelerated motion. Remember the first one, where a freely falling body, that was uniformly accelerated motion, whereas for the second one, the car traveling, it is non-uniformly accelerated motion. Also remember, if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal time intervals, then the acceleration of the object is said to be uniform acceleration. I am repeating, the object is traveling in a straight line. The increase or decrease in the velocity is equal in equal time intervals. The object is said to be uniformly accelerated. Okay. Example, freely falling body. Now, if the motion of a freely falling body is said to be a uniformly accelerated motion, whereas on the other hand, An object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. What does this mean? It means that a car is traveling along a straight road. Its speed increases in unequal amounts but at every fixed equal interval of time. Then the car is said to be moving in a non-uniform acceleration. Acceleration is nothing but rate of change of velocity with respect to time. With respect to time means in order with time. As the time proceeds, what is the change of velocity that has occurred in that non-uniformly moving object? Let us first understand the formula about to find out acceleration. If we consider the velocity of an object, the initial velocity of an object as u, and after some time the final velocity obtained by an object v, and that change from initial to final took place in time t, or if I measure time value of time in t, then acceleration would be rate of change of velocity, which is final velocity minus initial velocity with respect to time divided by time. So I get the formula as a is equal to, a means acceleration, is equal to v final velocity minus u initial velocity divided by time t. Okay. This kind of motion is known as accelerated motion. If I put in values to find out SI unit of acceleration, if I plug in values, if you remember v and u and t, if you plug in these values, you will get the unit as meter per second square. And acceleration is a vector quantity because we need to know where has the acceleration occurred with respect to magnitude as well as its direction. Okay. There are two types of acceleration which are shown on this type. Let's discuss about them. One is positive acceleration and two would be negative acceleration. In simple words, the acceleration is said to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. Okay. Let us see with the help of a numerical over here. Now, in positive acceleration, the initial velocity will be lower than final velocity. Take example, I have taken initial velocity u as 20, final velocity magnitude as 50, in time say 5. So if I plug in these values in the formula, a is equal to v minus u upon t, I get the answer acceleration as 6 meter per second square. Now, so see the sign, it is plus 6 meter per second square. In the second example, where we are considering negative acceleration, in this the initial velocity is higher than the final velocity. So initially the object was moving with velocity say 100 meter per second. Later the velocity at the final velocity it was 60 meter per second, and in a time interval of 4 seconds. If we again plug in these values in the formula, a is equal to v minus u upon t, we get the answer minus 10 meter per second. So this minus indicates there is either deceleration or the object is moving in the opposite direction as compared to its initial velocity. Okay. Let us try and solve one numerical based on this. Speed of a car changes from 80 kilometers per hour to 60 kilometers per hour in 5 seconds. Find the acceleration of the car and also comment whether the car has positive acceleration or negative acceleration. For every numerical, we need to first write down whatever is given. So here, speed of a car changes from 80 to 60, which means initial speed would be 80 kilometers per hour, final speed would be 60 kilometers per hour. Now note the time given is in seconds, so we have to convert speed, initial as well as final speed, into meter per seconds. Always solve whenever you are solving any numerical, make sure that all the entities are in the same SI metric system. If it could be kilometers per hour, then time also would be in hours, or everything converted to meter per second in this case. Now 80 kilometers per hour means 80 into 1000. Why 1000? Because 1 kilometer is equal to 1000 meters. So 80 into 1000 divided by 3600. Why 3600? Because it is hours. I need to convert it into seconds. So 60 minutes into 60 seconds. That is why 36. So I get the answer as 800 upon 36. Final speed also similarly 60 into 1000 divided by 3600. I get it as 600 divided by 36. Sometimes for numericals it would be better if we keep the conversions in fractions, because when we plug in these values in the formula, they make the calculations more easier. Now for those who find it confusing, you can convert it into decimals here only and then plug in the values. Either way it is fine. Just make sure that you write it down neatly. So we know the formula for acceleration is equal to final velocity, final speed, velocity minus initial velocity upon time, v minus u upon t. So acceleration A is equal to, plug in those values, 600 upon 36 minus 800 upon 36, the whole divided by 5. So now in the numerator I have 36, which is a common denominator, and if I calculate it further, I get the answer as minus 10 upon 9, and which is nothing but minus 1.1 meter per second square. This negative sign indicates that the car underwent deceleration.